Hello friends, today we are going to study about lipids part 1. In this part we'll study about introduction, storage lipids, how the carbon atoms in the lipid is numbered, cis and trans conformation, common saturated and unsaturated fatty acids found in biological system, and some physical properties of fatty acid. So first, introduction. Lipids are chemically diverse group, perform a variety of function in our body. These are insoluble in water. In lipids, fats and oils, these are the storage form of energy, whereas phospholipids, sterols, these form structural elements. Apart from this, the other function of lipids include enzyme cofactor, electron carriers, light absorbing elements, hydrophobic anchors for protein, chaperones, emulsifying agent, hormones, and intracellular messengers. So lipid comprise a very diverse group performing a variety of function in our body. Now first with storage lipids. Fats and oils, these are the stored form of energy and these are derivatives of fatty acids. Now fatty acid means these are hydrocarbon derivatives. The word hydrocarbon means they have a lot of hydrogen atom in their structure, and more of hydrogen atom means these are reduced compound with low oxidation state. And when any substance or any compound is highly reduced, then its combustion or oxidation will become highly exergonic. So that means oxidation of fatty acid is highly exergonic, releasing a lot amount of energy. These are carboxylic acids with hydrocarbon chains ranging from 4 to 36 carbon long. So fatty acids, this is an example of a fatty acid having a carboxyl terminal and a long chain of hydrocarbon which ranges from 4 to 36 carbon long. Now, if the chain contains only single bond, that is no double bond, then we call it as a saturated fatty acid. And if the chain contains one or more double bond, then we call it as a unsaturated fatty acid. Say for example, this is one saturated fatty acid. That is all single bonds and no double bond. And this is an example of unsaturated fatty acid having two double bonds. Now, this saturated fatty acids, because they contain only single bond, that means the rotation around each bond is allowed. Because of single bond, that is s orbital involving, they can easily rotate and they don't have any steric hindrance. Because of which, what happens is molecules of saturated fatty acids can tightly pack among each other because they don't have any steric hindrance. So they can come close together and are also stabilized by van der Waals forces. And because of which saturated fatty acids have high melting point because they don't have any double bond. Therefore, the rotation is allowed around every bonds, creating less steric hindrance, and because of which the molecules of saturated fatty acids, they can come close together and tightly packed due to van der Waals forces. And because of its tightly packed character, the saturated fatty acids have high melting point. Coming to unsaturated fatty acids, because they have double bonds, so that means the places in the molecule are there where free rotation is not possible, because of which they are not tightly packed like saturated fatty acids and have low melting point. Therefore, saturated fatty acids in the room temperature, they have a waxy nature or they are fats in room temperature, whereas unsaturated fatty acids are in the form of oils. Now, can you give the example of saturated fatty acids? Animal fats. These are mainly found in animal fats. And unsaturated fatty acids are mainly the product from plants. Now, how do we number the carbon atoms in fatty acids? This is an example of a fatty acid. The carbon is numbered from the carboxyl terminal. So this is carbon number 1, this is carbon number 2, carbon number 3, and so on. So the carboxyl terminal end is numbered as carbon number 1. But if we talk about alpha beta form, then in that case, the methyl group or this methyl end is known as omega. This is the omega carbon or the omega end. This group or this carbon is alpha, this is beta. So numbered wise, carboxyl terminal is the first carbon and so on. If we talk about Greek abbreviation, in that case, the carbon next to carboxyl terminal will be called as alpha carbon. Then beta and the methyl end is called omega. Now come to cis and trans conformation. Now cis conformation means, suppose these are the example of fatty acids. If a double bond is present in which the CH2 group are in opposite orientation. Here one CH2 group will be and here one CH2 group will be. So this type of conformation is called trans conformation. Whereas in cis conformation, the CH2 groups are present on the same side. So this conformation is called cis conformation. So both the conformation are for unsaturated fatty acids. Now because of this cis conformation, they produce a kinks in the structure, that is bends. Now if we compare the trans unsaturated fatty acid and the cis unsaturated fatty acids, which one will be better? The cis one is better because of this cis conformation, there generates a bend. So compared to these two structures, the trans will be more tightly packed compared to the cis ones. So that means trans will have the high melting point. Cis will have the low melting point. So compared to trans and cis, again, which one will be better for our health? Cis unsaturated fatty acids. Clear? If we compare saturated and unsaturated, then unsaturated is better. In unsaturated also, when we compare trans and cis, then cis is better compared to the trans. This is the list of some common saturated fatty acids found in the biological system. So from this table, what we can see is, see from here carbon skeleton 12 to 24. That means the common length of fatty acid which is found in a biological system have the carbon length of 12 to 24. Now how it is written? 12, 0. That means no double bond. So 0 means no double bond. That means this is a saturated fatty acid. Now in the systemic name, you can see N. N means normal. Normal means no branching. These are not branched. These fatty acids are unbranched fatty acids. So from here only you can see lauric acid, which is a 12 carbon skeleton long fatty acid. Myristic acid is a 14, palmitic acid 16, stearic acid 18, arachidic acid 20, and lignoceric acid is a 24 carbon skeleton long fatty acid. Now come to common unsaturated fatty acid in the biological system. Now how it is written? 16 is to 1. That means 1 means 1 double bond. It contains 1 double bond. Now here it is written delta 9. That means in the ninth position the double bond is present. That means between carbon number 9 and carbon number 10 the double bond is present. Now let's check how it is. The first carbon is the carboxyl end. So this is the first carbon. Then after first carbon, here it is 7 written. So that means total of 7 carbon is present here. So 7 plus 1, 8. So this CH is the ninth carbon. That's why it is written delta 9. Between carbon number 9 and 10, double bond is present. Similarly, 18 is to 1. Delta 9 means double bond is present between carbon number 9 and 10. Here 18 is to 2, delta 9, 12. That means 18 carbon skeleton long the fatty acid is consists of 2 double bond and the position of the double bond are 9 and 12. That means between carbon number 9 and 10 and between carbon number 12 and 13 are the double bonds. Now some physical properties of the fatty acid. Longer the fatty acyl chain, lower will be the solubility. It is clear because fatty acids are insoluble in water. So longer will be the chain, lower will be the solubility. Fewer the double bonds, lower will be the solubility. Because more the double bond is, more loosely it will pack. So it will be easy to solubilize. Less the double bond is, or when we see saturated fatty acid, no double bond, that means they are lower in solubility. The fatty acid chain is slightly soluble in water because they have one carboxyl terminal. So carboxyl group is a charged group. So the polarity comes from this carboxyl group. The saturated fatty acid at room temperature has a waxy nature, and unsaturated fatty acid at room temperature has an oily nature. This we already studied. That is why the saturated fatty acid is of waxy nature, because no double bond. No double bond means all single bond. All single bond means rotation is allowed, which means less steric hindrance or no steric hindrance. No steric hindrance means they can tightly pack with each other. If they are tightly packed, that means they will be less soluble and will be waxy in nature. The opposite is true for unsaturated fatty acids. But again, in unsaturated fatty acid also, we have trans and cis. Because of cis, bend generate in the fatty acid chain. Therefore, cis is good for health compared to trans. And one more thing, in the last slide, if you have noticed, there all the unsaturated fatty acids have cis conformation. That means all the naturally occurring unsaturated fatty acids are of cis conformation. Now, one question from my end for you all. The melting point of a series of 18 carbon fatty acid, like for stearic acid, oleic acid, linoleic acid, and linolenic acid, are given. For these fatty acids, the melting points are given. You have to tell me what structural aspect of these 18 carbon fatty acids can be correlated with the melting point. Do let me know in the comment section. If you found the video informative, please do like, share and subscribe the channel and hit the bell icon for the next video notification. Till then, stay safe, stay happy.